Hi everyone, in this video we'll take another set of functions in math module. So let's do it. The first function I'm going to talk about is reduce product function. This function computes tf.math.multiply of elements across dimensions of a tensor. Let's take an example. Let's first say we have this tensor, one-dimensional tensor, with just 3 elements in it. The first one is 4, and the second one is 7, and the last one 2. When we apply reduce product function on this tensor, the result equal to 4 times 7 times 2, which is 56. Reduce product function takes a bunch of arguments. The first one is input tensor argument, which is the tensor to reduce. This tensor should have numeric type. The second argument is axis, which takes the dimensions that we want to reduce by using reduce product function. The default value of axis argument is none, which means that reduce product function will reduce all dimensions. And if we want to set value to this axis argument, this value must be between minus rank of input tensor to rank of input tensor. The third argument is keep dimensions argument, which takes true or false. If it is true, it will return reduced dimensions with length 1. The last argument, name, which is a name for the operation. It is optional argument. Let's first import TensorFlow, like this. Now let's make tensor x. So x equal to TensorFlow dot constant, open parenthesis. Now let's make the first row in this tensor, which has these values, and the second row in this tensor. So here we have two-dimensional tensor. Here is the first row and the second one. Now let's apply reduce product function on tensor x. So let's type tf.math.reduce underscore product, open parenthesis. Now let's put the name of input tensor that we want to apply reduce product function on it, which is x tensor. And then we will specify the axis that we want to reduce. So let's type axis equal to, there are two axes in tensor x. The first axis is row axis and the second one is column axis. Let's take column axis. So we will reduce column axis of tensor x. Let's run this. And here's the result, as you can see here, which is a tensor as well, one-dimensional tensor. And here's the shape of this tensor. The first element in this tensor is equal to 1 times 3 times 5, which is 15. And the second element in the output tensor equal to 4 times 6 times 3, which is equal to 72. Now let's make keep dimensions argument equal to true and see the result. And here's the output, which is a tensor, two-dimensional tensor. And here's the shape of this tensor. The only change here is that keep dimensions argument make the length of column axis equal to 1 in the output tensor, which is the reduced axis in this case. Now let's reduce row axis. So axis equal to 0. And here is the result, which is one-dimensional tensor with 3 elements in it. The first element equal to 1 times 4, which is 4. While the second element is 3 times 6, which is 18. And the third element is 5 times 3, which is 15. Now let's make keep dimensions equal to true. And here's the results. As you can see here, here's the output tensor, which is two-dimensional tensor. Here's the length of the first dimension and the length of the second dimension. And the length of this dimension equal to 1 because of this dimension is the reduced dimension. Now let's take reduced standard deviation function. This function computes the standard deviation of elements across dimensions of a tensor. Let's take an example. Let's say we have this tensor, one-dimensional tensor, and the elements in this tensor are -2, -1, 0, 1, and 2. If we apply reduced standard deviation on this tensor, so the result equal to 1.4. If you want to calculate standard deviation by your hand, you can use this formula. Let's do it. The first thing you should know the axis that you want to calculate standard deviation for it. In this case, there's just one axis in this tensor. So let's calculate standard deviation for the elements in this axis. The first thing we should know is the mean of the elements along that axis. So x bar, which is the mean, equal to -2, -1, plus 0, plus 1, plus 2, divided by the number of elements in that axis, which is 5. And the result equal to 0. So now we know the mean, which is this part in this formula. Now let's calculate standard deviation. So standard deviation, we refer to it by sigma equal to, now let's put the root here, and under the root we will put the following. The first element, which is x1 minus the mean, which is 0. x1 here is -2. So -2 minus 0. And we will take the square of the result. Plus x2 minus the mean. So x2 here equal to -1 minus 0, and the results, we will take the square of the result. After that, x3 minus the mean, so plus x3 here is 0 minus 0, like this, and x4 minus the mean, which is 1 minus 0 square, x5, which is 2. So let's type this: 2 minus 0 square divided by the number of elements in that axis, which is 5. After we make the calculations, the result equal to 1.4. Now we will use reduce standard deviation function to make all these calculations. There are a bunch of arguments in reduce standard deviation function. The first one is input tensor, which is the tensor to reduce. This tensor should have real or complex type. The second argument, axis, and this argument take the axis that we want to reduce, and its default value is none, which means that reduce standard deviation function will reduce all dimensions, and the value of this axis should be between minus rank of input tensor to rank of input tensor. The third argument is keep dimensions argument. If it is true, returns reduced dimensions with length 1. And the last one is name. It is optional arguments. The reduced tensor or the output tensor has the same data type as the input tensor. There's just one exception. When the input data type complex 64 or complex 128, the output tensor will be of type float 32 or float 64. Now let's apply reduced standard deviation function on tensor x. Let's type tf.math.reduce std open parenthesis. Here we will put x tensor and we will specify the axis that we want to reduce. So type axis equal to, we will reduce column axis, so we will type 1. Let's run this. And here's the result, which is one-dimensional tensor, and here's the shape of this tensor. The first element in the output tensor, it is just a standard deviation of these elements, 1, 3, and 5. While the second element in the output tensor, it is the standard deviation of 4, 6, and 3. Now let's make keep dimension equal to true and run this. And here's the result. It is two-dimensional tensor, and here's the shape of this tensor. And the length of the reduced dimension equal to 1 here because keep dimensions equal to true. Now let's reduce the row axis. So axis equal to 0. And here's the result. The result is a tensor with 3 elements, one-dimensional tensor. And here's the shape of this tensor. And as we said before, the data type of the output tensor, which is a float 32 in this case, same as the data type of the input tensor x. Now if we want to make the length of the reduced dimension equal to 1, so we will type keep dimensions equal to true, like this. Let's talk about the output tensor, which is one-dimensional tensor with 3 elements in it. The first element in this tensor, which is the standard deviation of 1 and 4. While the second element, which is 1.4, it is the standard deviation of 3 and 6. While the last one, it is the standard deviation of 5 and 3. Now let's talk about reduce sum function. This function computes the sum of elements across dimensions of a tensor. Let's take an example. Let's say we have this tensor with 3 elements in it. The first one is 1, and the second one is 4, and the last one is 2. As you can see here, this tensor is just one-dimensional tensor, so there's just one axis. And these are the elements along that axis. Now, if we apply reduce sum function on this tensor, so the result equal to 1 plus 4 plus 2. So the result equal to 7. There are a bunch of arguments in reduce sum function. The first one is input tensor, which is the tensor to reduce. This tensor should have numeric type. And the second argument is axis, which take the dimension that we want to reduce. Its default value is none, which means that reduce sum function will reduce all dimensions. And its value must be in range between minus rank of input tensor to the rank of input tensor. The third argument is keep dimensions argument. If it is true, it returns reduced dimensions with length 1. The data type of the reduced tensor or the data type of the output tensor is the same as the data type of the input tensor. Let's apply reduce sum function on tensor x. So let's type tf.math.reduce underscore sum open parentheses. Here we will put the input tensor x. And now we will put the axis that we want to reduce. So axis argument equal to. Now we will reduce the column axis. So we will put 1 here. Let's run this. And here's the result. As you can see here, here's the output tensor, which is one-dimensional tensor. And here's the shape of this tensor. The first element in the output tensor equal to 1 plus 3 plus 5, which is 9. And the second element in the output tensor, it is 4 plus 6 plus 3, which is 13. Now if we want to make the length of the reduced dimension equal to 1, so we will write keep dimensions equal to true, like this. And here's the result. Here's the output tensor and the shape of the output tensor. As you can see here, the output tensor, it is two-dimensional tensor, and the reduced axis, the length of the reduced axis here equal to 1. Now let's reduce row axis. So axis equal to 0. And here's the result. Here's the output tensor. The first element in the output tensor equal to 1 plus 4, which is 5, while the second element in the output tensor equal to 3 plus 6, which is 9, and the last element in the output tensor equal to 5 plus 3, which is 8. And as you can see here, the data type of the output tensor, same as the data type of the input tensor. Now let's take the last function today, reduce variance function. This function computes the variance of elements across dimensions of a tensor. Let's take an example. Let's say we have this tensor with 5 elements in it. If we apply reduce variance function on this tensor, so the result equal to 2. If you want to calculate variance manually, you can use this formula, which is same as standard deviation but just without square root. So if we take square root for the result, so we will obtain the standard deviation, which is equal to 1.4. There are a bunch of arguments in reduce variance function. The first one is input tensor, which is the tensor to reduce. It should have real or complex type. The second argument, axis, which take the dimension that we want to reduce. Its default value is none, so reduce variance function will reduce all dimensions. And the values that can be taken by this axis argument should be between in range minus rank of input to the rank of inputs. The third argument is keep dimensions argument. If you set it to true, so it returns reduced dimensions with length 1. And the last argument, name, which is the name for the operation. The data type of the output tensor, same as the data type of the input tensor. But if the data type of the input tensor is complex 64 or complex 128, so the output tensor or the data type of the output tensor is float 32 or float 64 respectively. Now let's apply reduce variance on tensor x. So tf.math.reduce underscore variance open parentheses. Here we will put input tensor x and the axis that we want to reduce. Let's say axis 1 or column axis. Now let's run this. And here's the result. Here's the output tensor. The first element in the output tensor, which is the variance of 1, 3, and 5, while the second element is the variance of 4, 6, and 3. And the data type of the output tensor, same as the data type of the input tensor. If you want to reduce more than one dimension, so axis equal to like 0, 1. So here we will reduce the axis 0 and the axis 1. Let's see the result. And here's the result. It is just scalar value, 2.55. So here we reduced row dimension and column dimension at the same time. If you want to make the length of the reduced dimensions equal to 1, so keep dimensions equal to true. And here's the result, which is two-dimensional tensor. And here's the shape of this tensor. The length of the first dimension is 1, while the length of the second dimension is 1 as well. Thanks for watching.